Welcome to everyone. So thanks, Frederick, and because I supposed to start by 7:40, and you have given me 10 more minutes to for my presentation. It's 7:30 now. Okay, and before we go into this MongoDB talk, so I would like to know how many of you are actually into MongoDB. Okay, that's great. Okay, so here we are going to actually see about a ReplicaSet and Chatot Cluster, which is a feature in MongoDB, and we will see how we are not going into the deep details on that, but we will see an overview of what is it and what are some of the things that you can do to implement the things properly. Okay, and basically who I am. I have started my career as a MySQL DBA, and I'm from India, and then I switched over to MongoDB, and today I'm working both on MongoDB and MySQL. And I'm a trainer, and I have taken some of the trainings program, and apart from that I do scripting, reading, driving. So people who knows me actually calls me Guruji. That means it's a Hindi words which means that who shares the knowledge. So I would like to talk with everyone and share knowledge and get the knowledge. And now here I am. I'm a Perconian. So let's go into the agenda today, what we are going to see. So this is a ReplicaSet, and this is about for our HA, and see nowadays why we are using MongoDB mostly. So because it's robust and easy to use, and on the way you can create database and then write into the collections. So and again, so how about your data security, and how about your data availability? So this is one of the features that is available in MongoDB, where you can put your data in many places so that the people can access as soon as possible, and your application will be faster. And next is the Chatot Cluster, and we will look what is about a Chatot Cluster and zones and tags. And again, zones and tags are like for example, you have your data across data centers. Okay, you have something from Australia, and someone from China, and something from US. Okay, so if you want you have your customers to read from faster from US data center, you can use these zones. Okay, so by using these zones tags, you can actually make your data available easy for your customers, so your application will be faster. And tags is something that I will let you know in the future slides. And PSMDB, that's Percona MongoDB server. So why do you want to use Percona MongoDB server when communities MongoDB is available? That we will look into it. Okay, so let's go into the main topic, ReplicaSet. So it's basically about a HA thing. Okay, so you have primary, which means whatever writes you are going to do, you are going to write into this primary, and the data is getting replicated to the secondary. We call in MySQL world we call it as a slave. Here we call it as a secondary, and the replication is happening, and there are heartbeats going on between the servers. Okay, so they contact each other every time, and then they make sure that they are on network. Okay, so even if there is any issues happen between these servers, they will make sure that primary is always there, so that your application is not going to have any downtime. Okay, so that means, for example, if your primary is down, okay, so what happens, this heartbeat from these two secondaries checks that primary is down, there is no reachability. So it will do election kind of thing and make sure one of these secondaries becomes as primary. Okay, so this happens within seconds, so your application is not going to have really any long downtime. Okay, and this primary will take care of writes after that. And the special thing about here is today is we are not going to see deep into that how to implement all those things, but I will let you know how you can set your votings, election kind of things, because for example here your primary is down, you have here secondary, and you have here another secondary is here. Now which secondary should come as primary? So there is a voting goes on, election goes on, and one of the secondary becomes as primary, which gets more vote than the other secondary. Okay, so here we use a concept called votes and other concept as priority. For example, if both of the secondaries are having the same kind of data set and both has same votes, what happens? So you can actually make one of the secondary to become as primary and give preference over the other secondary. So in that place you can use the priority. Okay, so here there are two things, one is vote and another one is priority. So here we have seen primary, secondary, and another thing is called arbiter, that I will tell you about arbiter. So the primary is the one which takes all the writes, and the secondary you could put your reads on the secondary as well. So in this slide, so if you want to put your writes all into primary, and if you want to divert all your reads into the secondary, you are going to split your load. Okay, so this is actually a good thing. Okay, so in this way you can make use of your secondary as well. And other thing is like the secondary. The secondary can be possibly the potential primary. On failover, when the primary goes down, you can have your secondary as the potential primary. That means you have opportunity that, or you have option to set your secondary to become as primary or else priority 0. That means your application can still connect to your secondary, but if any failover happens, your secondary cannot become as a primary. Okay, so there are cases like, for example, you have some of your secondary servers in some data center which you don't like that secondary from that data center to become as primary. That means your application should not write into that data center. Okay, in that time you can make use of this option priority 0. You can set priority 0 here so that this secondary will not come as primary. So your application can read only from that secondary. The other thing is hidden. This is main thing here in MongoDB. For example, in that replica set architecture, you want to have the data, but your application should not see that secondary. In that case, you can schedule you can implement the secondary as hidden secondary. Okay, so when you configure that particular secondary as hidden secondary, that secondary will be in that replica set architecture, but your application cannot see that. So you can use those secondaries for backup purpose and or for any DR purpose. Okay, for example, if you have two data centers, and you have one data center as a DR data center, and if you want to have that secondary in that data center for any DR purpose, you can make it as a hidden. So your application is not going to actually connect to that, but still when on failover scenarios, you can make use of that secondary to become to change the configure and make it as a primary later. And the other one is delayed one. So you can make one secondary as a delayed secondary. That means, for example, you are writing for now for 740, you are writing one insert, okay, one data. So if you want that secondary to follow that writes after 1 hour, you can make use of it. So what happens when mistakenly some of the application is writing something and you want to fail over that, okay? So you want to reverse that, you can use these delayed secondaries. So this is about primary and secondary. So what about arbiter? So arbiter is no data member and it's for vote. That means arbiter is used only for participate in the election, okay? It doesn't actually contains any data. That means in this replica set architecture, you have only one secondary and one primary, okay? You don't have a cost to implement another secondary, okay? You don't want to spend more cost on that. So what happens if this primary goes down? This secondary cannot become as primary. Why? Because in election there is no other member to vote this secondary to become as primary, right? So we need someone to make, okay, you are the only available secondary, you become as primary. So we need someone to tell that, right? So for that purpose we have this arbiter concept, okay? So with this arbiter, you're not actually going to have any data here, but only for the election purpose, okay? So even if this secondary goes down, you can have this primary up and run always, because this arbiter will make sure this primary gets more vote, okay? So these are some of the states available. That means whenever you are starting the replica set, okay? So first it goes into the startup state, okay? First, after going into that, it goes into the startup 2 status, and after that it goes to the recovering status. That means in this phase it started getting the data, and then for example here you have primary, first primary, and you are going to configure one new secondary, okay? In that case that secondary will not, initially it will not be a secondary, because it needs to sync the data from primary first, right? So in that case, first it goes into this phase and then startup 2 phase. That means it connected with that replica set topology, and then it sees the data and doing the initial sync, and then it goes into the secondary one, okay? So this rollback is something like for example, your primary goes down and the other secondary has taken the role of new primary, okay? And the old primary is now coming up. But you see there are some data which has been written into that old primary but not replicated to the secondaries yet. So in that case it needs to do rollback. So this rollback means whichever the data written into the old primary but not yet replicated to the new secondaries. So in that case it writes into the rollback directory inside the data directory itself, so that later you can decide whether you need to apply those writes or not, okay? And this is primary state. And arbiter, you know, unknown is something like unknown and down are something like when you're checking the configuration from other node, okay? And you may see some of the nodes which looks like down. That means it's not reachable, okay? Some of the nodes which are in the configuration, but the status of that node is not available. And removed in the sense that particular node is removed from the replica set configuration. So when you are actually connecting to MongoDB, you will see this status in that prompt. So when you are connecting to the MongoDB prompt, you will see these things, okay? And who can actually vote? That means whenever the election happens, who can actually vote? So only the states, the MongoDB instances which has these states can only participate in the election. For example, if one particular server is in startup state, okay, it cannot participate in the election. So you need to make sure only these things are, these states can participate in the election, so that you can make sure that, for example, maybe in some of the cases, like see here, you have primary, secondary, and secondary. This secondary, in some way it went down, and again it is coming up. Okay, it won't come up as secondary directly. First it goes to the recovering phase, and then from that recovering phase it comes to the secondary phase. While coming into that phase, what happens if this primary goes down? Okay, so this is this secondary is in recovering phase, so it can owe to this secondary, and this particular secondary can become as primary. Okay, so you need to know these states so that it would be helpful for you to understand the election process. And sorry, so here you can actually have the application to write both reads and writes into the primary and keep this secondary without any load. Okay, so this would be helpful when you are having high configuration in the primary and there is less configuration on the secondary. Else you want to read all your writes. Okay, you don't want to lose any writes when you are reading. Okay, so in that case you can have this configuration. That means you are writing something here, and so in some way, due to some network issue or something, your secondary is taking that write after 1 minute, but you are reading your data immediately after writing it. What will happen? So in those cases of on those application kind of things, you can have this thing. Or else here there is another concept called write concern. That means I think in MySQL world we talk this about like a synchronous replication. So whenever you are writing into master, you have to make sure when you are using the synchronous replication, it makes sure that your slave is also getting that write. Okay, so in the same way we have a concept here called write concern. If you set that value, so the default value of that write concern is 1. That means when you are writing into the primary, your application will get acknowledgement from your primary alone. Okay, so when your write concern is 2, that means it should get acknowledgement from 1 primary and 1 secondary. Here if you have write concern as 3, that means it needs to get acknowledgement from this primary and this secondary as well. So it's if you want to make sure that all your writes should go into the secondaries, so that when there is any failover, when your secondary takes care of a primary role, you have all the data intact. Okay, in that case you can have these write concerns properly. But the problem with that write concern is you have some network issues. Okay, but you have write concern as 3. What will happen? So your application will wait for acknowledgement forever, and your further writes will not happen. So there are some you have to choose whether you need a write concern on top level, or you can have these failover scenarios. Okay, and you are okay with that write concern with a low value. Okay. And this thing, like you can have your writes into primary alone, and you can have your secondaries to have all the reads. So in this way you can I told you, right, you can have write concern so that your secondaries will get all the writes properly. Okay, and it again depends on your applications. Okay, some of the application doesn't need to have all your recent data, or some of your application needs all your recent data as well while you're reading it. So it depends on that. And yeah, again I talked about write concern. So set proper priority. That means I told you, right, whenever the failover happens, you need to have that priority properly set. What happens, like in this case, you have 2 secondaries and your election is going on, your primary is down, and one of the priority of one server, secondary server, is 10. Okay, and another secondary is having 5. Now the priority the secondary having priority 10 will become as primary. when the old primary comes up, it has the priority 20. What will happen? It joins as secondary actually, but it sees that priority as 20, but the current primary is having 10, so it will call for again election. So if you set priorities unevenly in all members, it will call for elections again and again. So you need to make sure that you are setting the proper priority. Fault tolerance, again, like in this one, if you are having 2 nodes went down, you cannot have single node as primary. So you need to make sure that you have enough members in the ReplicaSet configuration, so that even 1 or 2 members goes down, you have enough members to vote, and then your primary is up and running always. And arbiter, use it wisely. So you have arbiter for voting purpose, so use it wisely, so that you will have primary up and running always. Okay. And tags and reads, it's something like I told you, right, the right consent thing. So you can, when you are having your secondaries in multiple databases, you can assign tags to them. So that, for example, one of your writes, you want to make sure particular application should write always into Russian database data center always. So you can tag those secondaries as Russian tag, so that all your writes goes to that particular tag, and then it makes sure that all your writes go into that particular data center. Okay, so something like that. Okay, so you can make sure your tags are properly done. And let me go to the other Sharding cluster. So this is something like we have seen this ReplicaSet thing, and this is the Sharding cluster, something like for example, you have 1 terabyte of data. In ReplicaSet, you need to have primary 1 terabyte and secondary 1 terabyte, and everywhere you need to have 1 terabyte, and you need to assign disk as a 1 terabyte. What if you don't want to do like that, and if you want to split your data and keep it in multiple servers? In that case, you can use this Sharding cluster. So by sharding, you can split your data and keep it in multiple servers. Okay, so this works in 3 components. One is router and config servers and shards. This is where in shards where your real data resides, and config server has your metadata about data. That means it knows where your actual data is. Okay, and Mongo is something your client connects to MongoOS. You cannot actually directly connect to the shards or config server. So you have to connect, your application has to connect to through MongoOS. So MongoOS will fetch the metadata from config server and goes to shard, particular shard, and gets the thing. And how is your this I told you. So this is something like sharded thing. Okay, so you can you have choice to shard or unshard as well. If you want to keep some collections unsharded, you can keep them as well. And when you are keeping those unsharded things, it goes into the primary shard. That means even though you have multiple shards, for when you are sharding one particular database, you will have particular shard as primary shard. That means whatever writes going, it goes into that particular shard first, and then it gets split and then goes to the other shards. Okay, it's not like that you are going to write shard 4 directly, shard 3 directly, shard 2 directly. For that particular database, shard 1 is the primary shard. First the writes goes to shard 1, and then from shard 1 it gets distributed through other shards. So we call that process as balancing. Okay, so how that Schottky. So for example, those data get distributed shards, right? How that those data are getting distributed? That's with this Schottky. You will have an index created on the particular collection, and you mention that as a Schottky. So when that particular index takes care and then decides for example, if you have index on ID, from ID 1 to 10 value goes to shard 1, you are mentioning like that. 11 to 20 goes to shard 2, something like that. Okay. So the chunks, so for example, you have multiple documents. First it gets into the chunks of data. Those chunks gets distributed across the shards. So we have seen that. So you can do with hash sharding or range sharding. Okay, so based on these things you can shard your cluster. And the problem here is like, for example, if we are not having proper shard key and your range falls into one shard itself, what happens? So all your data resides in one shard itself. So you need to make sure you are having proper shard key chosen as well. Okay, so this is something you cannot change after chosen one time. Okay, you have to drop and then create again if you want to change. So you have to make sure about that. And zone is something like isolate data across this thing, like, so you can assign data across the geographically. So for example, if you tag some shard as, for example, here I have gender data male, and then I want all male data should go to shard 1 and all female data goes to shard 2. I can assign like this. Okay, so shard 1 gender male A, tag A, shard 2 gender female, tag B. Okay, so this is about sharding, and I think my time is over, and I think I have covered all those things. And again, other thing is like backup. You have to make sure your backup is properly done, and that backup is used for restore as well. Not only backup is doing is important, restore is as well. Okay, thank you. So please write to me in this mail ID if you have any doubts. Okay,
tell them that you'll do a webinar for the rest.
You're planning to do a webinar, right, for this, so you can tell.
Yeah, so I'm planning to have a webinar for this, so that you can please subscribe to our Percona blog, and you will receive a notification about that. So you can see these things in detail in webinar. Okay, thanks.